Every year, the world produces over 20 million tons of polystyrene foam packaging.
This petroleum-based material takes 500 years to decompose.
But nature has engineered a revolutionary solution: mushrooms. The secret lies in mycelium, the vast underground network of fungi.
This living organism can grow into any shape while bonding materials together.
Welcome to one of the world's pioneering mycelium packaging factories.
Here, agricultural waste becomes the packaging of the future. The process begins with locally sourced agricultural byproducts.
Hemp, corn stalks, sawdust, materials that would otherwise be burned or landfilled.
Each batch undergoes quality inspection to ensure clean substrate.
The material is mechanically processed into uniform particle sizes.
Smaller particles provide more surface area for mycelium colonization.
Next, the substrate is sterilized to eliminate competing microorganisms.
High-temperature steam treatment takes just minutes, not hours.
The sterile substrate cools to room temperature in clean rooms. Meanwhile, mycelium is cultivated from carefully selected fungal species. Species like Ganoderma and Pleurotus are chosen for their binding strength.
This pure mycelium spawn is the living ingredient of the packaging.
Now comes the crucial inoculation, mixing mycelium with substrate.
Automated systems ensure precise and consistent distribution.
Each packaging piece starts as a 3D computer design. Custom molds are 3D printed from recycled plastic.
Each mold is designed to perfectly fit the product it will protect.
The inoculated substrate is carefully packed into the molds. Mumpilful tribes.
Gentle compression ensures consistent density throughout.
Filled molds enter the growth chambers where magic happens.
At 25 degrees Celsius, mycelium begins its remarkable transformation.
Within 24 hours, white threads emerge and spread.
By day 3, the mycelium network becomes clearly visible.
Day 5 reveals a nearly complete transformation. After 7 days, the material is fully bound and self-assembled. Millions of microscopic threads create a strong, cohesive structure.
The living material has grown into the exact shape needed.
At this stage, the packaging is still alive and 50% water.
Heat treatment stops the growth and creates the final product.
At 80 degrees, the mycelium dies and water evaporates.
Precise temperature control ensures consistent product quality.
The result is a lightweight, durable,
and completely inert material.
The final product performs identically to traditional foam packaging. Every piece undergoes rigorous quality inspection. Density, strength, and dimensional accuracy are verified.
Compression tests confirm excellent shock absorption properties. Drop tests prove protection equals or exceeds polystyrene foam. Natural water-repellent properties protect contents during shipping.
Unlike petroleum foam, mycelium packaging is naturally fire-resistant.
Insulation values match or exceed conventional packaging materials. The secret lies in millions of air pockets within the structure.
Approved packaging moves to the distribution center.
From electronics to glassware, mycelium protects diverse products.
Dell pioneered its use for shipping servers and computers.
IKEA committed to replacing all polystyrene with mushroom packaging.
Luxury brands embrace it for premium product presentation.
Insulated coolers maintain temperature for perishable shipping.
The food industry benefits from natural antimicrobial properties.
Brands can customize with logos, textures, and specific shapes.
Production costs now rival conventional foam packaging. The 7-day growth cycle enables rapid production scaling. Carbon emissions are 90% lower than polystyrene production.
Mycelium grows at room temperature, requiring minimal energy input.
Agricultural waste becomes valuable resource instead of landfill burden.
Local farmers gain additional income from their waste products.
Local sourcing eliminates long-distance petroleum transportation.
Customers appreciate the soft, natural feel and eco-friendly message.
The texture creates a memorable, premium unboxing experience.
After use, the packaging simply breaks apart for disposal.
In home compost, it biodegrades completely in 30 to 90 days.
The nutrients return to soil, feeding new plant growth.
While styrofoam persists for centuries, mycelium returns to nature.
No microplastics, no forever chemicals, no ocean pollution. Research continues to enhance strength, speed, and versatility.
Different fungal species offer unique material characteristics.
Substrate combinations are optimized for specific performance requirements.
Automation increases production capacity and consistency.
Production facilities are expanding across Europe, Asia, and Americas.
The global market reached €68 million in 2023.
Industry analysts project tenfold growth within the next decade.
Legislation worldwide increasingly bans single-use polystyrene.
Major corporations pledge plastic-free packaging by 2028.
73% of consumers prefer biodegradable packaging options.
Younger generations drive demand for environmentally responsible products.
Social media amplifies awareness and consumer education.
Educational initiatives inspire future biotechnology innovators.
Academic partnerships drive continuous material innovation.
Home kits allow enthusiasts to grow their own mycelium materials.
Artists explore mycelium's potential in furniture, art, and design.
Beyond packaging, mycelium creates construction and fashion materials.
Let's. Bio-insulation panels offer superior thermal performance.
Mycelium leather replaces animal products in fashion industry.
Acoustic applications utilize mycelium's natural sound dampening properties. Furniture designers create chairs, tables, and lighting from fungi. Agricultural containers decompose naturally after plant transplanting.
Medical research explores antimicrobial wound healing applications.
3D printing technology enables custom architectural components. Biotechnology merges with manufacturing to revolutionize materials. Venture capital investment reached $6 million in recent funding.
Hundreds of patents protect emerging mycelium technologies.
Global conferences accelerate knowledge sharing and adoption.
International standards ensure quality and environmental claims.
Comprehensive life cycle analysis confirms genuine sustainability benefits.
Among bio-alternatives, mycelium offers unique advantages.
Scalability allows production to meet global packaging demand.
Economies of scale make mycelium cost-competitive today.
Mycelium integrates into existing packaging supply chains effortlessly. No special storage or handling requirements and simplify logistics. Mycelium packaging actually sequesters carbon during growth.
Switching to mycelium reduces pressure on planetary boundaries. The industry creates sustainable jobs in communities worldwide.
Workforce training programs prepare the next generation.
Challenges remain in moisture control and product standardization.
Ongoing research develops solutions for performance optimization.
The future envisions completely circular material economies.
Living materials may soon incorporate sensing and computing capabilities.
Biofabrication represents a paradigm shift from making to growing. Nature and technology collaborate to solve human challenges.
Future generations will grow up with truly sustainable materials.
From farm waste to protective packaging and back to soil.
The choice is clear: pollution or regeneration.
Mycelium packaging proves nature has been engineering solutions all along.